Good morning, friends. Today we are going to discuss about mainly brazing and little bit of soldering. And this is an important process and very specifically to join dissimilar materials and sometimes the components for electrical conductivity. So what is the brazing process? Brazing process is for joining two pieces of metal that involves the application of heat and the addition of the filler material. So there are three varieties of welding mode. One is autogeneous one, another one is homogeneous, and the third one is heterogeneous. Autogeneous means there is no requirement of the filler material, that is called autogeneous. Many of the welding process like say electron beam welding or laser welding, they are suitable for autogeneous. Homogeneous means the metallurgical composition of the filler material will be very similar with those the participating material or metals which have to be joined. So there are uniformity in terms of metallurgical construction of the filler material and the parent material. So that is called homogeneous one. And what is heterogeneous? Where the filler material metallurgical composition is different from that of each of the parent material. Why it is different? The different is that sometimes we have to join very challenging two dissimilar materials. We have to go for this intercaste or interreligion marriage. Welding is just like joining, it is just like marriage. So whenever we are ensuring the marriage of two dissimilar metals, very specifically different melting point, so we have to have a filler material which is in between in terms of the properties so that it can make a very sound joint. So this kind of welding mode is known as heterogeneous mode. So in brazing also those kind of things are there, because brazing has some applications in terms of the tool tip or tool inserts and all those things, tool part of it, front end part of it. The reason is that the tool we require and the front end, it should be very hard, it should be very wear resistant, and the shank part of the back end which should be very tough. So which is hard, not tough, which is tough, not hard. So different things we have to do in the tool, in the front end part and in the back end part, and in order to integrate that we need sometimes the brazing one. So it is a process of joining two pieces of metal, involves application of heat and addition of filler material. So it is mainly use of filler material is there, and this filler metal which has a lower melting point than the metals to be joined is either pre-placed or fade into the joint as the parts are heated. So that has a lower melting point so that we can easily melt the filler material and ensure that the joining of it, sometimes those participating material, they are not fully melted, only the filler material is melted and it will share the common pull, and because of the melting these two components of the metal will be joined together in the coalescing surfaces, and that way the brazing will be ensured. Brazing is a very popular way of joining things in case of the tool tip along with the shank tool material, and that is a tremendous advantage because we need some conflicting property of hardness and toughness to be required in the different parts of the tool. So also some cases we can have all those some kind of attachment in the conventional places that can be brazed, and gas and oxygen will be used in order to heat the material, and those two attachment with some kind of say pipes and some kind of attachment for the different purpose and applications. And with the filler material, with the gas and oxygen, it will be just heated so that the molten metal will act as an agent in order to bring the coalescence between those two parts. So brazing can be utilized appropriately for those kind of cases. And the filler material used may be divided into two different classes. One is copper based alloys and another one is silver based alloys. And there are a number of different alloys in each class, but brass, that is nothing but the alloy of copper and zinc, and sometimes with 20% tin SN, and they are mostly used because this copper, zinc, and tin, all those things can be strontium. Tin is nothing but the strontium. They can have an appropriate alloy, and they can be easily melted together, and on the basis of these melting they can act as a very good joining agent between these two different parts in order to ensure the joint. And because of these melting range from 850 degrees Celsius to 250 degrees Celsius are used mainly for brazing the ferrous metals. The ferrous metals melting point is much above than these things, that may be say 1535, 1545, 1575. So the parent material will not melt even at the coalescing surfaces. Only the filler material of these copper or silver alloys will melt, and they will share the common melting pool, and because of their melting and then solidification, they ensure some kind of adhesion between these two surfaces of those participating ferrous metals. So this is one form of strategy. And the other group of thing is that the silver alloys, silver and copper, or silver, copper, zinc. So those appropriately combine in order to have all those melting range between 600 and 850 degrees Celsius, suitable for brazing any metals capable of being brazed. This is again a heterogeneous welding. Why heterogeneous welding? If we want that the participating metals also in the coalescing surfaces will be melted, the problem is that it becomes uncertain, because fusion welding mainly is associated with a localized casting, so they also inherit some of the perennial problems and defects related to these casting process. So it is better to go for lower heat zone, so that the heat affected zone has and the thermomechanically affected zone is limited. So brazing can give a very good solution. That way the participating ferrous metals at the coalescing surface will not be melt, and only the filler metal, and that is of a different variety and different melting point, will melt, and ultimately it will be a common melting pool, solidification, and because of the solidification it will ensure the adherence of those these solidified filler material with the coalescing surfaces of the two, and good enough appreciable level of the strength will be there, and these two parts will be joined. So very good pragmatic solution, joining all those part of it without involving the appropriate melting of those required melting of those coalescing surfaces, and that gives a lot of advantages in terms of operations, in terms of application. And the advantage is that they give a clean finish and strong ductile joint. So that is the advantage of braze, that it will give a very good finish. Many a times, because of lot of melting is taking place of the coalescing surfaces along with the filler material, this surface finish and other things are not great. But brazing can give very good surface finish, because we are not ensuring the good amount of melting material of the parent metals, and that way it is possible for brazing as a technology to give better clean finish and ductile joint. And ductile joint, the advantage is that the joint can accommodate, joint is not very rigid, so that little bit of forces and other things will not make it very vulnerable. That is the advantage of the ductility part of the joint. And what is the difference between brazing and soldering? The main difference between brazing, arc welding, is the heat source. The heat source is applied via torch or furnace or induction dipped or a resistant as a heat source, and occurring at temperature above this 450 degrees Celsius. Temperature is above that. That is the marking difference between those soldering and the brazing. Whereas arc welding uses electricity at a very high level, very high level plasma state. And whenever we are inflicting that plasma state at the time of welding, lot many uncertainties in terms of manufacturing defects and other things will creep into the system. If we can do all sorts of joining in a very lower temperature than whatever the plasma state of the arc, then definitely lot many uncertainties, the possibility of generation of lot many uncertainties will be restricted to a great extent, and that is the really a great selling point of the technology of brazing. So temperature near about or just above these 450 degrees Celsius, that is the brazing temperature in most of the cases. And the problem is that in arc welding, whatever we have told, because of the higher temperature, lot many extended heat affected zone and all those things will be there. So here, as the temperature is lower, then these kind of possibilities will be less. And welded joints are usually stronger than the base materials also. Because of this melting and then solidifying, that all depends upon the filler material. And brazing differs from welding is that the temperature is considerably lower, whatever we have already told, and does not melt the base metals. That is the biggest advantage of the brazing. The base participating metals are not get melted. The striking advantage of the solid state welding is that no part is melted, and brazing is, yes, the filler material is melted, but not the participating material is melted. That is the great advantage of the brazing process, and the heat source melts a filler material and draws into the joint by capillary action. The capillary action allow it to flow down to those intricate and appropriate places to form a sound joint without ensuring the melting of those participating ferrous metals, because 850 degrees Celsius or near about that, the ferrous metal will not melt. We have to go for 1600 degree, and whenever we go to that level of temperature, the problem is that the dimensional distortions and those problems of the localized casting in the form of welding will come. Advantages, it has some definite advantages. The advantages of joining metals by brazing are that dissimilar metals, they are the biggest challenge. Intercaste and inter-religion marriages are great challenge, because they are coming from the different culture, so different formation, metallurgical, and if we want to make them a sound integrated joint, that is always a challenge. So brazing is a very good solution for joining dissimilar metals and parts having a very thin section also. Thin section joining sometimes difficult, because very difficult to ensure the joint. So brazing with the filler material at lower temperature melting point, they can ensure these kind of joining. So that is a tremendous advantage, because today's technology demands for many of the cases where the very thin and precise materials has to be joined very specifically for the aerospace industry. They don't want that extra weight what can be gained for the very big heat based welding process. They want a very precise and sound joint, and where these components and parts are of a different character because of their applications. So they demand these kind of things. So brazing can be an answer to those kind of situation, provided that all those cases they don't go for a very difficult and exotic situations where temperature is very high. So brazing is used for the fastening of the pipe fittings. Many of the cases, the pipes, the flanges and other things has to be put across all those pipes. So the handles, the tanks, the credible tips of the tools, so that is important, because tools may be of the tungsten carbide and other kind of things which are very wear resistant and hard. But if we make the tool full of tungsten carbide, because of the hardness, it will be very brittle. So, or ceramic tools, another part of it. So if we do that, the entire tool, it will be breakable and it is not workable. So front end, the different one, and the back end will be different one, and these kind of dissimilar materials in terms of the metallurgical composition. Brazing can have a very good purohit, very good clergyman, in order to ensure the marriage between these two dissimilar metals. So those kind of things will be there in radiators, heat exchangers, electrical parts and all those things. It should be parts, sorry for the printing mistake and the typing mistake, and the repair of those castings. So it will be there associated with all those kind of things, because joining all those components are very challenging with the arc welding, because sometimes these electrical parts they will be just have a detrimental effect if we put into the plasma state environment and all those things. So brazing will be a solution. So this is used for fastening of pipe fittings. In the piping industry, brazing is a very good solution provider. Carbide tips on the tools, the ceramic materials and other things in the front end part of it will be there. Heat exchangers, electrical parts, radiators and different kind of attachment with these axles. They can be very good industrial applications of brazing, and it can join also cast metals to wrought metals. That is a very challenging one. Metallurgically they are very different, cast metals and wrought metals, dissimilar metals, porous metal components, because if we go for arc welding, because of the melting of those things, the porosity will be compromised. So brazing, if we are going for at lower temperature, definitely all those porous materials and other things, the porosity will not be compromised. So we can join two porous metals or one porous metal with the other. That is possible very much there by the brazing process. And it is used to join the parts of the bicycle, such as frame and the rims. Again, two dissimilar, maybe arc welding is not at all fitted for those kind of things. So we can have a sound joined at lower temperature, that will be done. In case of soldering, the main comparison is that soldering is only to ensure the electrical conductivity, where the strength is not at all the important criteria. In case of brazing, it is stronger, but we require a lot of heat in comparison to the soldering process. Soldering is mainly done by the lead, because lead melting point is much lower, and lead will ensure the conductivity of those materials. But slowly and steadily, these soldering process is getting eliminated by some kind of adhesives which are capable of conducting material. So those adhesives, and the beauty is that even when we don't have to do melting. So main difference between welding, brazing and soldering is that soldering, the strength of the joint is less, not required that way. Brazing, the strength is more, and brazing is done at elevated temperature near about above 450 degrees Celsius, where soldering is mainly done at the melting point of the lead, just to ensure the electrical conductivity between the electrical and electronic components. So disadvantages, there are different disadvantages, because brazing has some problems. So lower strength joints compared to welding. Definitely arc welding can provide much sound joints, because their concept is melting everybody, melting the coalescing surfaces, melting the filler material, truly share the common melting pool at very high temperature, even for the ferrous metals. And the plasma state will ensure that kind of heat source, and according to that joining. So joining is sound, and many of the time you will find it out that the strength of the joint is more than that of the parent material. That is the unique selling point of the arc welding process. That is why it is so popular. So that kind of sound joint, if we want, so brazing is not the solution, not the answer to that. So lower strength and producing joints that are not as well suited at high temperature application. Obviously, the filler material is having a lower melting point, maybe say 850 degrees Celsius, all those copper and all those alloys. So definitely, if we go for even the melting point or near about the melting point or above 1000 degrees Celsius, the filler material will simply melt away, and the strength will be of the joint will be totally compromised. So if we want to have these kind of applications, exotic applications, where the temperatures and other things are of a very high order, definitely the brazing will not be the solution, because there will be the melting of the filler material, and the joint will not exist between these two components. And these fluxes also, that is also sometimes a problem. Fluxes may contain the toxic components related to the filler materials and all those things, and these toxic components are not very friendly for this environment and for those operators. So that possibility is also there. So there are metals which are difficult for brazing because heating metals like silver or gold to such high temp requires a lot of precision. So precise applications are required. It is more common for these metals to be soldered rather than brazed. So ferrous metals, brazing, yes, but in case of silver or gold, as because their melting point and other things are very, very low, and these kind of filler materials and other things cannot have a very good joint. So it is better to go for soldering than going for the brazing one, because brazing also call for some kind of elevated temperature, not as that great as the arc welding, but still it is. So golds and all those things in the ornaments business, gold and silver, jewelry, these kind of brazing operations may not be suitable in some cases. And gold and silver can handle the lower heat better, and soldering can still give a good bond even if it is not as strong. Good bond, so lower temperature, it will be great for the gold and silver. So whenever gold and silver and those kind of handy joints, soldering is a much preferred option than that of the brazing. So that will be there. And that is the thing in terms of strength, in terms of the heat. That is the main difference between brazing and soldering. Brazing is higher temperature in comparison to soldering, but better joint. Soldering lower temperature, not as strong buoyant, but it is very handy for those materials like gold and silver because it is doing in a much less elevated temperature. So this is the main crucial differences between the brazing and soldering. Thank you very much for your patient hearing about the topic of brazing and soldering. Thank you.